We're going to look at a situation where we're given a rational function, and in this particular case f of x, and we're saying that if f of x is made up of a ratio of two other functions, we'll call this p of x and q of x, that are in standard form, with no common factors other than 1, then the function f of x has zeros, in other words crossing the x-axis as you graph this, at each real value of x for which the function in the numerator is equal to 0, and vertical asymptotes, that is lines going up and down through the x-axis at each real value of x for which the bottom rational function is equal to 0. So let's take a look at a specific example. So if you're told to identify the zeros and asymptotes of this function, and this function is made up of 3x squared minus 27 in the numerator and x squared minus 36 in the denominator, the first thing we're going to do is to locate the zeros of the function. And again, the zeros are if you're given a graph, xy coordinate plane graph, and you have some type of a function like so, and I'm not saying that's what this looks like, but it could be that every time that this graph crosses the x-axis so that the y coordinate is 0, whatever the value is of x in that ordered pair, that is called the 0. So what we're saying is that in this particular situation, we're going to set 3x squared minus 27, which is the numerator, equal to 0. And we're going to solve for x. Alright, so the way we do that is we factor out a common factor between 3x squared and minus 27 is 3. So it's kind of like distributive property in reverse, if you will. So we're going to take out the 3, and we wind up getting, if we factor out a 3 out of 3x squared, we're left with x squared. If we factor out a 3 out of 27, we get 9. Now, here, what we have is a difference of two squares, x squared minus 9. That can be further factored into x plus 3, and x minus 3. All this is equal to 0. Alright? So, what do we know about things being multiplied together equal to 0? Well, the zero product rule tells us that if your answer to the multiplication is 0, then that means each of the individual items we set to 0 as well. So, well, 3 can't be 0, but that does leave x plus 3 and x minus 3. So let's set each of those equal to 0. X plus 3 equals 0, x minus 3 equals 0. Alright? Now, solving for those two equations, we get x is equal to negative 3 and x is equal to 3. So those are our two zeros. So whatever graph we're going to draw is going to cross the x-axis at those two positions.